This is the video for our Super Saturday session from 2/27/16. This is the makeup assignment on theorems. If you turn the page, there is a sheet that has all three theorems: intermediate value theorem, mean value theorem, extreme value theorem. I'm going to start with extreme because this just basically says you have an absolute max and a min as long as you have continuity on a closed interval. Okay, that was the one we started off with. Then we went to intermediate value theorem. Again, we only needed continuity on a closed interval, but it had to do with basically you got to go through it. If you have a y value down here and you have a y value up here, you've got to cross it at least once. We can see in this picture we've crossed 3 times. We're going to do this in an example here in a minute. And then mean value theorem was the one we did after we found out about derivatives, because we still need continuity on a closed interval, but we also need differentiability. Just to kind of jog your memory, this is the one where the average rate of change should equal the instantaneous rate of change, or the derivative. Okay, so I'm going to start with example 1. I'm not going to go over every one in the video, but this is a good one to start with. If we have continuity on a closed interval and differentiability, we can use any of our theorems: EVT, IVT, or MVT. So this is what we need to kind of look for. I would just start, instead of just going one at a time, think which one talks about there being an absolute max or min, because this, we have the conditions for it, and that's C and D. Okay, and we're looking for the one that could be false. Okay, so it's not C, it's not D, because those have to be true. All right, what also has to be true is anything having to do with intermediate value theorem. All right, and so I'm kind of just looking at these and thinking none of them really look like intermediate value theorem, because we're not talking about a y that's in between, you know, f of a and f of b. It would look something like this, okay, with some number in there. Okay, so that didn't happen. So now we go to mean value theorem. This right here looks exactly like a mean value theorem. Here we have IROC, here we have AROC. And so that has to be true. That's mean value theorem right there. So it can't be A. Okay, so then we get to B, has to do with a derivative, maybe mean value theorem, and then we get to E. When you're kind of running out of theorems, just think logically which one could be false. Do we know anything about this function? No. So I don't know that the derivative is 0. Okay, that would mean that you know, the derivative, this function could look like this, where the derivative is just the same number the whole time, or where there are no maxes and mins. Okay, what E has to do is basically like fundamental theorem of calculus. Okay, does the integral exist? Okay, you might want to pick this one, but and I can understand why, because it's the kind of odd man out. But B, we know for sure, could be false. Okay, the next problem we're going to do is number 6, and I'm going to go through, and any one I skip are ones you're going to do on your own unless I tell you to skip it. Okay, so let's go down to 6, and here we have a function. It's trig. We have an interval, and it says that it satisfies the condition, so I don't need to think about anything else. Which of the following could be C? So we need to consider where AROC and IROC equal each other. Well, AROC would just be simple slope, f of 3 pi over 2 minus f of pi over 2 all over 3 pi over 2 minus pi over 2, y minus y over x minus x. And you got to do a little bit of work here to figure out, you know, what is 3 pi over 2. So if I plug this in for this x, I end up getting sine of 3 pi over 4. Okay, because of the over 2 makes an over 4. And then if I plug pi over 2 in, I end up getting sine of just pi over 4. And down here you end up just getting a pi. Alright, so then we got to think about, okay, well, we've got all students take calculus, we've got SOHCAHTOA. Sine is positive in the first and second quadrants, and this 45-degree angle gives us root 2. It's going to be the same thing, root 2 over 2 minus root 2 over 2, both positive, so this whole thing gives me 0. Okay? So then I come over here and I do IROC. All right, this is derivative. So I need to find the derivative of sine of x over 2. So that's going to be cosine, leave the inside alone, and then chain rule. What's the derivative of x over 2? You don't need quotient rule here. It's just 1/2 because x over 2, that's the same as 1/2 x. So you just need to multiply by 1/2. So now I need to set these two things equal to each other. Okay, I'm just basically plugging in a 0 here. So the 1/2 here ends up like not mattering at all because you could just times 2 to each side or whatever. So we just have 0 equals cosine of x over 2. And so we've got to solve this. We've got to think, okay, where does cosine equal 0? That's why I'm doing this one on this video, because it has a lot of trig. Right up here, cosine equals 0. All right, so what that means is that the inside, that x over 2, will equal arc cosine of 0, which is this angle, which is pi over 2. So that means that x has to be pi. And we just want to make a quick check, is it in the interval? And it is. Okay. All the ones I'm skipping, you are going to do. This packet's not very long, so I'm not going to have you skip that many. I am going to allow you to skip number 14. It's not a bad problem, it's just there's a lot of repetition, so both parts of 14 you can skip. Okay, then we get to some free response, and we're going to go over 16 together. Okay, this is a table. AP Test loves these table problems, and generally they're not that bad. Just got to know how to read the table. So notice that we've got differentiability, and if we have differentiability, we also have continuity, so we can use all of our theorems. Then we have this other function. Okay, now at any point I'm going to have to explain something. All right, it's just good to go ahead and get right out front that, and again, you're going to have more room on the AP test, but that h of x is continuous and differentiable on 1, 2, 3. Okay, so it's just good to go ahead and say that so that if we ever need it, we're not going to forget. That's the conditions. All right, now it says a value of r such that h of r is -5. This is not talking about a derivative or anything. We're just saying why does there have to be a -5 inside there? So this is intermediate value theorem. So basically I need to find h of 1 and I need to find h of 3, and I need to show that -5 is going to be in between these two values. So let's just use the formula. F of g of 1 minus 6, and so that would be f of, and then just look up on the table, g of 1 is 2, and then f of 2 is 9, so 9 minus 6, that's 3. Do the same thing for h of 3, using the formula, using the table. G of 3 is 4, and f of 4 is -1. So -1 minus 6 is -7. Okay, so we can see here clearly that -5 does go in between these two numbers. Okay, so we need to say something like, since -5 is in between, so h of 3 is less than -5, which is less than h of 1, and have all my work up here to back that up. By intermediate value theorem, h of r equals -5 for this interval. Okay, and then the next one talks about, okay, now we have a derivative, so you got to be thinking, okay, what theorem has to do with derivatives? Mean value theorem. This is where AROC equals IROC. So let's go ahead and find the AROC of h. Let's do h of 3 minus h of 1. What we're hoping here is that it's going to equal -5, which would be the derivative of h, the IROC. Okay, so h of 3, just found it up here. That's -7. H of 1 is 3. I can see this coming together already. This does equal -5. So because the average rate of change equals -5, the instantaneous rate of change has to equal -5. Okay, so by mean value theorem. So I already listed the conditions up here. You don't have to list them again. That's why I went ahead and did both. Even I didn't need the differentiability for IVT. I do need it for MVT, so it's just good to get it out of the way. By mean value theorem, h prime of c equals -5, and then always relate it back to whatever interval that they told you to use. Okay, the last one that we're going to do together is number 18. Okay, so 17 you're going to do on your own. Here's another table, and it's just one part. And if you want to pause and take time to read this, you can. But it's basically saying, you know, f double prime has to equal r on this interval. So I'm going to kind of highlight that piece of the table. What is r? Give a reason for your answer. Okay, so I don't have an f double prime column. If I did, I might be thinking about IVT, but because this f double prime is the derivative of f prime, I'm thinking MVT. Okay, so I'm going to go ahead and list out the conditions. F is continuous and differentiable on, and then I'm just going to list the whole interval, although it would be sufficient to list this little interval right here. I'm going to quote a theorem. I've got to say that somewhere in the problem. Okay, so again, mean value theorem means we're a rock. So sorry, I don't know why I did H. F of 0.5 minus f of 0 over 0.5 minus 0. So look it up on the table. F of I apologize. Because we're doing f double prime, I need to do a rock of f prime. So f prime of 0.5 was 3. F prime of 0 is 0. So we end up getting 3 over 0.5, which is the same as 3 divided by a half, which is going to give you a 6. Okay, so that's what your r equals. R equals 6, such that f double prime of c equals r. Okay, this is by what theorem? By mean value theorem. We've already listed the conditions, we listed the average rate of change. It follows naturally that should be it. So all the ones that I didn't do and we only skipped 14, you need to do those and get those turned back into me.